For this week's assignment, we will be finding the symbolic representation of exponential functions. So when we try to find the symbolic representation, remember we have to find the constant ratio, the initial value. Now for this first page, we know the initial value is 1. So you just have to find the constant ratio, and it talks about that up here and some specific values. For the next 2 pages, you have to find both because the initial value won't be 1. Okay, so for each one, the process is the same. So I'll do one example problem here, and we'll also work more on it during class. So remember, the general form that we want for these functions is f of x equals the initial value times the constant ratio to the power of x. So you look here, in this example, they give us 2 values. P of 3 equals 20, P of 4 equals 40. So when the input is 3, the output is 20. When the input is 4, the output is 40. So first, let's find our constant ratio. How we do is say, okay, P of 4 divided by P of 3 will give us our constant ratio. So what do we have here? We have 40 over 20 equals 2. So our constant ratio is 2. That makes sense because 2 times 20 is 40. 4 times 2 would be 80, etc. Okay, now to find the initial value, we just plug in. So you know, let's use this value here, P of 3 equals 20. So let's see, P of 3 equals C times 2 to the power of 3. And we know P of 3 is 20. So we can substitute 20 over here for the output. So 20 equals C times, let's see, 2 to the 3rd power, that's 8. So we divide by 8, so C equals 20 over 8. So going up here, C, let's see, 20 over 8 is, there's several ways we can write it. We could write it as a decimal, or we could simplify this. So 20 over 8 is the same thing as 5 over 2, so 5 halves. So we just plug that in for C. So our answer is P of x equals 5 halves times 2 to the power of x. And again, our initial value is right here, 5 halves, and 2 is our constant ratio. So here's our answer. Now, if we wanted to find a specific value, for example, if we wanted to find P of 5, we could solve that fairly simply. So we have 5 halves times 2 to the 5th power. That's 2 to the 5th power is 32. That simplifies to 5 times 16, which is 80. And we can see here that would be the same thing. 40 times 2 is 80. So you could get the answer several ways. You could also, if we tried to graph it, we would know we'd start at 5 halves. And we know P of 0 should be 5 halves. Okay, this is just to show that we can apply this, find the values. And 5 halves times 2 is 5, times 2 again is 10, so again is 20, so it agrees with what we're saying. So the main step is to find this though. So again, remember first find the constant ratio, That's the base for the exponent. Then we plug in to find the initial value. We got it to be 5/2, and that gives us our symbolic representation. So if you have any questions, please ask. We'll go over this more in class. And I will talk to you later.